Okay, now let's move on to the next topic, which is the computation of whole number. Under that, we have the first main heading, which is the predecessor and the successor. It's a very simple concept. Let's say you got your favorite number, right? Cool. Okay. Now, if you add 1 to it, you get what's called the successor. Picture this. You roll a dice, you get your lucky number 6. Now, add 1 to it, bam, and you're looking at 7. That's the successor of 6. Same drill. If you're, let's say, vibing with 10 and add 1 and you're cruising with 11, that's nothing but the successor of 10. So successor is a very easy concept to understand, wherein to whatever number we have, we add just 1 and we get the successor of it. Therefore, when it comes to the whole numbers, there is no end to it. When it comes to the natural numbers, there is no end to it, because whichever highest natural number you can think of, when you add 1 to that, you will get the successor of that, which is also a natural or a whole number. We know that every natural number is a whole number, so that's there. Then, when it comes to predecessor, it's nothing about the number before the main act. For example, let's say you throw a dice and you get 5, and the number which is before 5, or when you subtract 1 from 5, what is that you get? You get 4. That is nothing but the predecessor of 5. So it's just like the number that warmed up the stage before the headliner. That means the one which came before. So when you add 1 to your digits, you are in the successor town. Moving forward, subtract 1 and you are back in the predecessor land, reminiscing about the good old numbers that came before. So that's the math of the streets, my friend. Okay. Now that is about predecessor and successor. Let's look at the whole number. We have already, but as I said, there are repetitions here in the notes, because this is not exactly the original notes prepared by the institute. They have heavily borrowed from NCERT. That's why I said this is one such topic where you would be mostly revising even when you're studying for the first time, because it's not something which is new. So what we can understand from this is, each number possesses a distinct narrative characterized by its antecedent and subsequent counterparts. That is what we studied now. So wherein we have the successor and the predecessor. Okay. So now, one thing which we have to understand here is, even though we took various examples like 5's predecessor was 4, 6 successor was 7, etc., etc., when it comes to 1, what is the predecessor of 1? See, earlier when we only thought of natural number, the predecessor of 1 was -1, because if you think of natural numbers, it will be 1, 2, 3, 4, 5, 6, like that. There is no predecessor to 1. Of course, there is successor, which is 2. So then what did we do? We threw in 0 to make sure that 1 is not left alone and it has 0 as its pre-party chill spot. So that is what it is. And in the next section, we have what we have already seen, that is the whole numbers and natural numbers comparison. I don't think we need to get into this again, but let me just skim through this quickly. All positive integers, including 0, are whole numbers. We already know this. Positive integers, be careful, because the whole numbers, as we just know, so it starts from 0. If it's natural number, it starts from 1. Real numbers are whole numbers. That also we have seen in the previous session. Whole numbers make up for all the nature's numbers. Fine. All natural numbers except 0 begin with 1. All natural numbers, okay, they will have to start with 1, of course. Yes, the smallest whole number is 0, because before that we have integers. It will not be considered as a whole number. Okay, natural numbers are regarded as whole numbers, although fractions, decimal and negative numbers are not. Of course, we have different terminologies for each of this. We have already seen that, so I won't get into the others because it's a repetition of the same thing. So once again, we have the same whole number line, natural number line, repetition. So we can just strike this off. So now we are looking at different properties of whole number. So that is what we'll be looking at with respect to whole number, starting with addition property. This is a very simple rule which says adding 0 to any whole number is like a math superhero with no costume change. Math superhero with no costume change. That means nothing happens. Add 0 to 5. it still remains the same. You can think of 0 as the math ninja that leaves things unchanged. No matter which number it is, add 0 and the number remains the same. So that is the addition property. So then comes the closure property. So now imagine your numbers are all friends at a party. The closure property says if you add or multiply two friends, the result is always part of this squad. For example, there are 4 friends and 10 friends, bam, then we have 14 friends who are all part of the same party. Okay, and since we are talking about the party, let's think of it as a party of whole numbers. We have 4 as one whole number and 10 as another whole number. Okay, so now even when I multiply these two whole numbers, we are still in the same party of whole numbers because we will get 40 as the resultant whole number. So no outsiders allowed here. That means when a whole number is multiplied with another whole number, the resultant figure will still be a whole number. So that is about the closure property. Then comes the associative property. In this case, picture this. Multiplication and addition are chill with how you group the numbers, meaning no matter how you group them, for example, whether it is 3 into 10 or 10 into 3, the resulting figure will still be 30, no? Right? Whether it is 3 into 10, which is 30, or 10 into 3, which is also 30. See, the grouping is reversed in this example, but still the last result is still 30. Okay, same goes for addition as well. 3 plus 5 or 5 plus 3, both will give us only 8. So math surely doesn't care about the order of the numbers when it comes to whole numbers. Then we have the multiplication property. This one is actually straightforward. Multiply any number by 1 and it's like looking in a mirror. You get the same number back. 8 into 1, it's 8, bro. But throw 0 in the mix and it's like, oh, it's a different story now. 0 into 7, it's 0. Because any number multiplied by 0 will be a 0 itself. Whereas 1, it's like looking into a mirror. So that's about the multiplication property, where we looked into what happens when it is multiplied by 1 and what happens when it is multiplied by 0. Then comes the division property. This division by 0, that is what we are looking into here, is like asking your math teacher for the answer to the meaning of life. What's the meaning of life? It's undefined. It's a mystery, right? So here also, if you divide, let's say 7, or in this case they are given 7. Okay, so let's make it 17. Doesn't really make any difference. 17 by 0. What is 17 by 0? The math teacher will say, sorry, it's like life itself. We do not know what's the meaning of it. It's undefined. It's a mystery. No one can answer that one. Undefined territory. So the answer in this case would be not defined. Whereas the reverse is not the case. 0 by 17 is easy. It's 0 itself. Because 17 multiplied by 0 is 0 itself. Whereas this, that is 17 by 0, is undefined. Then comes the distributive property. Imagine you have 3 numbers, A, B and C. It's like this distributive property is like a DJ at a math party. No matter how you mix and match, you'll still get the same number, same result. For example, A into, sorry about that, A into B plus C, okay, equals A into B plus A into C. So if this is confusing, let us take up numbers itself instead of alphabets. 1 into 2 plus 3. How much is this? 3 plus 2 is 5. 5 into 1 is 1. Is equal to 1 into 2 plus 1 into 3, which is also 5, because 2 into 1 is 2, 3 into 1 is 3, 3 plus 2 is 5. Think of any number instead of A, B, C here, or P, Q, R as the material has considered. You will still get the same answer. This is referred to as distributive property. Then lastly, we have commutative property. In this case, imagine you have again A, B and C as friends. So here also we have the same thing. Even if you swap, let's say they are dance partners. the resulting figure will still be the same. So P plus Q, I'm just considering the same example here, is same as Q plus P. Okay, so if I have to take an example, 15 plus 16 equals 16 plus 15, same 31. Okay, so that is what we have in case, in commutative property. All these are very easy properties, and these are all obvious things which you already know. That's why I said this is more of a revision session. Okay, so that was all about the properties. In the next part, we'll look into the rounding of fractions. Before we move towards the sample questions on whole numbers, there is one small topic which is rounding of fractions. Let us quickly go through this and then proceed towards the sample questions. So now, with respect to rounding off, there are only two rules which you have to understand. See, the rules are very simple. One is a decimal which is less than 0.5. If the decimal part is less than 0.5, then you round off to the lower whole number. For instance, if the decimal is 6.3, now look at the decimal part. 0.3 is less than 0.5. Since 0.3 is less than 0.5, we will round off to the lower whole number. The lower whole number of 6.3 would be 6 itself. If it was instead 6.5 or above, meaning the decimal part, if it is 0.5 or above, that is greater than or equal to 0.5, then we round up to the next whole number. If it is less than 0.5, we round down. If it is equal to 0.5 and greater than 0.5, we round up to the next whole number. For example, 6.5 in this case becomes 7. Same thing with 3 also. Let me just add a page here. Just give me a second. So now in this case 3.5, since it is equal to 0.5, it becomes 4. Round up. 3.4 round down, which will be 3. So that is the whole funda behind the rounding of decimals. Only thing is we have to look at the decimal part. Less than 0.5, round down. Equal to 0.5 and above, then round up. So if I have to look at few more examples, it would be like this: 9.2. So now the decimal part, only look at the decimal part. If it is 0.5, if it is less than 0.5, round down. So I will round it off to 9. If it is 0.5 or above, then I will round up, which will be 10. Yeah, we can think of a number of examples. Let's say 12.9, more than or equal to 0.5, so round up. 12.4, less than 0.5, so round down to 12. So in summary, what we can say is rounding off simplifies the decimal numbers by considering whether the decimal part is closer to the lower or the higher whole number. It's a practical way to express values in a more manageable form, especially in the real world scenarios where precision is not that critical. So that is the whole funda behind rounding off of the fractions. Okay, now let's look at the sample questions on the whole numbers. Let's look at the first one. The first one says a number in which 1/5 part is increased by 20 is equal to 1/10 part of the same number increased by 30. Find the number. Of course, we have the answer here, but let us try to find out how to arrive at the answer logically. So we do not know the number yet, so let that number be x. So now the first part of the question says 1/5 part of that number, if it is increased by 20, 1/5 part of that number will be calculated first, which will be increased by 20. That means we'll have to add 20, will be same as the same number, and considering 1/10 of that number and increasing that by 30. So this is the equation which we are looking at. X into 1 by 5 plus 20 equals x into 1 by 10 plus 30. So we do not know what is that x, what is that number. So let us try to identify that number. So if I have to write down in the form of equation whatever I wrote down earlier, 1 by 5x, since x into 1 by 5 is 1 by 5x, plus 20 equals 1 by 10x plus 30. So now what we can do is to simplify, we'll get rid of the fractions and consider only the whole numbers. So for that to happen, what we'll do is we'll multiply by the largest denominator here, which is 10. So what I will do here is 1 by 5x plus 20 into 10 equals 1 by 10x plus 30 into 10 again. So when I do this math, 5 ones are 5 twos are 2 into 1, 2x plus this will be 10 into 20, so that will be 200 equals, here also 10 gets cancelled, so it will be x plus 30 into 10, 300. This is the simplified form of the equation. We can of course further simplify here. So what I'll do is I'll just bring this to LHS and this I'll take to RHS. So 2x minus x will be 300 minus 200, so x will be 100. So the number in question in this case is 100. Now all that we need to do is verify. So once again let us go back to the question. A number in which 1/5 part, that is 100 into 1 by 5 plus 20 will be equal to 100 into 1 by 10 plus 30. So 5 20s is 100 plus 20 equals 40. So 10 into 10 tens are plus 30. So therefore 40 equals 40. LHS equals RHS. That solves the problem. Okay, now let us look at the next question. The product of two numbers is 150 and the sum of squares of numbers is 325. So we'll consider two numbers as a and b. So the product of two numbers, that is a into b is 150 and the sum of the squares, that is a square plus b square, is 325. Find the sum of both the numbers. They are not asking us what are those numbers, but instead they are asking us to find the sum of both the numbers. So now one thing which we can do here is, since they have asked us to find out the sum, let me just write it down. A plus b whole square. I will use this formula for the simple reason that we know the variables in the formula. For example, if I have to expand this formula, this will be a square plus 2ab plus b square. That is the expansion of a plus b whole square. So now in this case, what is that we know? We know a square plus b square. We know ab, that is 150. All that we have to do is multiply that ab by 2. So a plus b whole square, whole square will be a square plus b square, a square plus b square plus 2 into ab. If I have to simplify, I'll just use right here, there is no space there. So a plus b in our case is how much? What is that? A square plus b square, no? So that in our case is a plus b whole square equals a square plus b square, which is 325. Plus product we know is 150, but 2 into ab, so 2 into 150. So this will be 325 plus 300, which will be 625, which is a plus b whole square. But the problem here is they have not asked the sum of both the numbers square, but instead they have asked sum of both the numbers. That means this square should be removed. So if I have to remove that, what I can do is I will shift it to RHS. So when I shift the square to RHS, it becomes square root. So 625. So that will be 25. A plus b therefore equals 25. So that is the thing. Now let us look at the next question. This is a very easy question, nothing much is happening. Which is the largest 4-digit number divisible by 91, they say. So 9919, 9900, 9909. So we in fact don't need these choices at all, because all that we need is the number which is given, 91. First, do one thing. Think of the largest 4-digit number. The largest 4-digit number is anyway 9999. All that you need to do is divide this by 91. When you do this, you will actually get the answer. So 91 times 91 ones are 91. 9 minus 1 will be 8, and we can carry down only one number, that is 9 from here. But we are left with 89, which is actually less than 91. So we cannot divide. So I'll add on 0 here. So this will become 890. So now we know 91 into 10 is 910. So therefore 10 is not possible. So 9, the previous number we'll consider, which will be 9 ones are 9, 9 nines are 81. So in this case, how much are we left with? 10 minus 1, 9, 1, 8 minus 1, 7. So some fraction will come into picture. So basically the answer is 109 with some remainder. So what we need is to multiply 109 by 91. So this will be 109 itself. 9 nines are 81. 9 ones are 9. So 9199. So the largest 4-digit number which is actually divisible by 91 is 9919, which is option A. So that's how we arrive at the answer. Again, in the exam it will be difficult because you are not allowed to use calculator. So even without using calculator, as I solved here, you can still do it. But this is one of those problems which the institute, I don't know for what reason they ask such questions. So be it. Let's not worry too much about that. If the number is 61xx4 is divisible by 6, then what will be the value of x? That means 61,000 something. Okay, that something we do not know because that is x and x. Then what will be the value of x? Okay, this again is very difficult to solve straightforward without looking at the options. Options here are 4, 5, 6, 7. One way of solving this would be simply substitute all these one by one. For example, 61,444 divided by 6. Is it possible? Okay, so let's check this. 61 10 times. Okay, let me just use the other sheet here. 61 444. I'm just replacing x by 4 divided by 6. 61 tens is 60. 1 4 6 twos are 12. 2 4. I'm just carrying down here. So then 6 fours are 24. Nothing is left. Then I'll have to carry down 4, but 4 cannot be divided, so I'll have to use a decimal here. Something will 0 will be added. So 6 5s are 40. So obviously not working because it is not perfectly divisible by 6. We have to use a decimal here, so that is not working. Then 61 instead of 4, I will now replace it with something else, which will be 5. 61 10 times is 61, then 5 carried down, 6 twos are 12, then 3 carried down, so 3 remainder, then 5 again carried down, 6 5s are 30, 5 carried down, and 4, when I bring it down it is 54, and we know 6 9s is 54. So therefore that xx should be replaced by option B, which is 5, and then the number would be perfectly divisible by 6.